right. Hi, everyone, and welcome to the first episode of the APS Podcast. My name is Anupam, and I will be your host today. So before we begin, just want to give you a bit of a background. The intent behind behind creating the APS Podcast is to engage business experts and entrepreneurs from various disciplines and discuss the unique business offerings. Now, on this podcast, we will be navigating the challenges faced by these business experts and their businesses, and we'll try and deep dive into the role of technology in their respective fields. Now, since I'm new to the podcasting world, I'm aware that mistakes will be made. And while I will try my best to give you a crisp and refined content, please allow me some time to get better. Now, constructive feedback and comments are welcome, as it will allow me to improve the overall content and format of the future podcasts. Our guest today is Daniel Couton. Daniel is a PhD qualified process environmental chemist who runs his own consulting company based in Brisbane. He has more than 20 years of experience in water treatment across a wide range of industries and countries. So, without further ado, let's invite Daniel. Welcome, Daniel.
Thanks.
So, Daniel, thank you. First of all, thank you for taking the time to join the podcast. This is the first podcast I'm doing like ever. So I will make some mistakes. Apologies up front. However, let's try and get into it straight away. So to begin with, could you just give us a bit of an introduction and background about who you are and what your company Aqual does and stands for, please?
Sure. So I'm a process and environmental chemist. My background is I did chemistry at uni. I went to go work out in industry for a couple of years, which was in primarily mineral processing, so big chemistry pilot plants, that sort of thing. And that was the first time I got to see chemistry as a continuous process. So prior to that, I'd done everything in sort of small batch processes, on a bench. But I saw big chemistry and I fell in love with it. So I was keen to get involved in that side of things, for a larger scope and larger size of chemistry. So I kept my eyes open. I went back and did a PhD. So it was an industry focused PhD.
Yeah.
And then that was sponsored by a state water authority, and basically just immersed myself in drinking water for the next sort of 3 to 4 years, and leaving. So I pretty much finished my PhD before I went out and got another job. I decided that academia wasn't for me, so I didn't really want to hang around too much longer.
Right.
But when I looked for a job, I ended up falling into a role with an engineering consultancy firm. So, started with them, and I've been doing consultancy, so as a chemist, but in an engineering environment for 25 years now. And so the company, essentially, my company Aqual provides, scientific services to engineering projects.
All right. Thanks, Daniel, for that lovely introduction. Now, we often hear about scientists. As soon as we hear the word scientist, people start to get, oh, he's a scientist. What does he do? And yours is an interesting area of expertise. You're a scientist, you're a PhD, and you are an engineer. So can you explain how a scientist works in engineering, or like an engineer, please?
Well, I'm not an engineer, and that's important because I'm not allowed to sign off an engineering drawing, so I can't design anything.
Right.
So where I help, I guess, is so I've always said engineering is the application of things that are known, and science is investigation of the things that are unknown. So, right. So if you have a good idea of how you want to do something, and there's applicable standards, you roll out and you do that, and that's a skill set, that's an art. But where I've sort of made a bit of a niche myself is two areas. Number one is when there's not a standard that's applicable. And so so I get involved in a lot of R&D projects, like industry-focused R&D projects, where they're saying, okay, we don't know, or there might be a component of a process, or so on a flow diagram, it'll be a black box. We don't know what goes in here. Can you help us out? Either come up with the process or select the process. And the second area, I guess, where I sort of help out is where a process has gone wrong. So troubleshooting.
Yeah.
Because when I first started in engineering, I discovered that engineers do and have to take a number of assumptions when they're making a design. So someone would say, this process will give you 5 milligrams per liter of nitrogen coming out the other end. I'm like, well, how do you know that? Because I'm a scientist. No, I don't know that unless I test it. But through many applications, 99.9% of the time that is true. It will deliver 5 milligrams per liter. But I get involved when it's 10, 20, or it's not delivering the 5 milligrams per liter. So the engineering is sort of, I guess, as I spoke about, from a larger scale, looking at things. But I'm looking at the same process that an engineer's designed or designing, but at a molecular scale. So what's happening at the molecular scale? Why isn't it working? Or what could we do to improve it?
Interesting. So in layman terms, basically, I consume water from my local provider. Now, if they were to engage your services, that would be one of the examples which you gave, which you just provided, was if the chemical composition of that water supply went up more than expected.
Yeah. So the engineers and the scientists will work together, especially for something like drinking water. So the engineer will be responsible for the design and operation of the network,
right?
The dosing systems, the hardware, if you like.
Yeah.
But the scientists would be involved more in maintaining the water. Well, when I say maintaining, investigating water quality. So if something's gone wrong, they should be going in and having a look, say, okay, what went wrong, what caused this? How do we fix it? They can get involved, like someone like myself who's got 25 years in engineering can probably go a few steps further, and I can recommend some processes. But ultimately, the engineer will design and implement that process into the whole system.
That's quite an interesting area for myself, because I worked in telecommunications for many, many years. And while I understand the intricate details of how it's all designed network-wise, because people are so used to just literally turning on their devices and there you go, you've got the internet and it works. Same with water, you just turn the tap on and what is there, right? But not many people give it a thought that how exactly is it coming to your home? Where is it coming from? What's required in between to get you clean water that you can drink and utilize for your day-to-day purposes? So that's quite interesting to know.
There's a lot of work. There's a lot of work goes into, people just turn their tap on, and that's the way it should be, right? If the water utility's done their job correctly, then they just turn the tap on. They don't have to think about it. I've got family from overseas, and they get very nervous when they see me turn on the tap and drink straight from the tap here. You can't do that. Well, we can do that here because there's lots of money, lots of people. Thankfully the government provides sufficient funding to make sure that all the checks and balances are in place to that water's safe to drink.
And that's a very important point. I think that's where we can say we are quite lucky to be in Australia, because I've traveled a fair bit and so have you. And I cannot name one country where I've been confident enough to just turn the tap on and drink it straight from the tap. I always have to go and buy packaged bottled waters, and I never actually bother asking. It's my fault, I get it. But usually you just have that confidence, right? That you can just turn the tap on and the water should be safe for drinking. And that's one great thing about Australia, I guess. And thanks to people like you who are doing the hard work to get us the clean water. So thank you for that.
Well, I'm not. I mean, my PhD was in drinking water. Now I've sort of drifted off into industrial, sort of more industrial wastewater. Like drinking water's the challenge with drinking water comes from the volumes and they do a hell of a lot of monitoring. So people say, I don't know if it's that. By the time you drink water out of that glass, it's been monitored many, many, many times. So it's safe. And the Australian drinking water guidelines are some of the strict, well, if not the strictest, some of the strictest in the world. They're very thick. There's a lot of, and the other thing is you've got separation of the two entities. So the water provider needs to answer to the state health department, and so the state health department is the watchdog, if you like, making sure that they're compliant with the Australian drinking water guidelines and doing everything they can. And unfortunately, even though we're in a privileged position because we live in major cities, so we can drink the water. There are places in Australia where you can't drink the water, and I've done a lot of mining work in remote areas where the water is trash to start off with, and we've got limited resources available, and it's also but I like these projects. This is a challenging project where the guy who is employed to chop the onions in the kitchen is also responsible for running the water treatment plant, which is sat next door. So it's a different mindset when you're approached. You can't assume that you can take some liberties again. When you know that the person that's operating your plant has formal training and 20 years experience and can call on a whole lot of resources from a pool versus some guy who's never seen it before.
No, makes sense. Makes a lot of sense. All right, moving on to the next question. I'm sure there'll be a lot of technologies you guys use within the industry. So what technologies are commonly used in drinking water?
I think so the majority of it is you're trying to remove things that are either not dissolved in the water or dissolved in the water. So if it's not dissolved in the water, usually filtration. And filtration has sort of come a long way. So, in the old days, you'd use sand filters or multimedia filters. They still use those. But in the sort of the 25 years since I got involved in the industry, I think that one of the major breakthroughs has been membrane technologies, so membrane filtration. So membranes have got a lot cheaper, and a lot better. And so the main thing about membrane filtration is it allows you to shrink your plant dramatically. So you can force water through at high pressures. And that does two things. Number one, it gives you a huge flux through the membrane. So instead of requiring a very large filter to get that flow rate through, something like a sand filter or a multimedia filter, you can make it much smaller and pump it harder and get the same amount of water going through there. Yeah, that's probably one of the biggest changes in technology that I've seen. The other things like advanced oxidation processes. So as we've become more aware of, my PhD was actually in disinfection byproducts. So what that is when you chlorinate water or you disinfect water using any disinfectant, it reacts with organic material that's in that water, and that breaks down into undesirable, they call them disinfection byproducts. But you get stuff that's easier. If you can think of it as like chemical burning, or you're blowing it up. So things like chlorine, bleach, that sort of thing. That's what's typically used in drinking water. But that essentially what that does is chemically burn things like microbes, and it will burn any really organic material to some extent. But they've discovered you'll get particularly pathogenic species that are resistant to chlorine. Yep. So they've upped the ante. They sort of crank it up to 11, and they've got these advanced oxidation processes, and they hit really hard. So
interesting. So do you use any, is there any utilization of IoT, Internet of Things, different kind of technologies?
Oh, absolutely. And I think that's, so old days, all the, when the operator was running a plant, there'd be local readouts, so local readouts, and then the operator would have to do a lot of adjusting. And then you'd get local controllers. So they were smart in some respect, where they would read, for example, an in and out, and they could adjust locally a dosage rate, for example, a chemical dosage rate. But now it's got, currently, I don't know if you've heard about programmable logic controllers, PLCs. So
I've heard the term, but I have not actually.
So essentially, it's just an empty brain that you can plug in, so you can have many inputs, and it can do the PLC is essentially a computer that can do whatever calculations you want. So you can it's programmable. You can make it do whatever you want. So it can be looking at two variables, but it can get very, very complex. And what that does is it takes the onus of the operator away, where they don't have to be constantly monitoring everything, which is obviously hard. But it allows systems to be run and monitored remotely, which is great. With the inclusion of telemetry, which is sort of standard now. That's also, I can be sitting here as an operator and be monitoring an entire state in terms of like drinking water. So I've been to an operations room for a water provider, and it looks like the deck of Star Trek. There's just thousands of monitors around, and I've got no idea what it is, but the guys obviously there, say, "Oh, we've got something." So they can monitor water quality, they can monitor, temperatures, pressures, all these sort of things throughout the whole system, and remotely turn things on and off. So that's which is good, because then you don't need necessarily somebody on site to do the work, which saves you money. It keeps people safe, because a lot of these things are remote, especially, as I said, but with membranes, they're not sort of super high, but you're dealing with high pressure fluids. So you don't want to expose people to risks, even chemicals. Like why would you have somebody near a chemical? And the chemicals that are used in drinking water, it's that old saying, everything is a poison. It's the concentration that counts. So, they'll buy in bulk chemicals like chlorine. Now, chlorine's fine. You can drink it. It's proven for the last 150 years to be very, very safe. But you don't want to drink neat chlorine, concentrated chlorine. People did that during COVID, and it didn't end well. So, but it's, keep remote operation, remote monitoring, being able to see everything all at once, so that the guy sitting in the because some of these plants are quite big, obviously, and somebody can be sitting in a control room and say, "Hey, can you run down and have a look at pump number 6, because something's happening there?" So he knows before the guy who's on site knows that there's something happening with that pump. And the other thing, which I've seen, I haven't really seen it in my line of work, troubleshooting. I can, if somebody can turn up with an iPad, I can see the site anywhere in the world and have a look at things, and I can say, can you stir that? Can you do that? Or whatever I would need to do if I was on site. I can ask them to do something there, which is good. And also, there's a lot of, as I said, I haven't seen a lot in the drinking water industry, but augmented reality. So where you can put on AR glasses, and then so you have to switch out a pump, but you don't have the manual on it. Well, you don't need the manual, because with the AR glasses, you can pull up the manual, the manufacturer's manual. You can have the support guy from the manufacturer in your ear telling you what to do. He can see what you're doing and give you instruction. And then there's the next level where you can actually see components inside. So you say, you have to get to a particular component where you can look into using AR. You say, "Oh, that's where it will be," and it knows where your spot.
And that's pretty cool. I mean, you don't hear that every day. I mean, thank you for sharing that. It's obviously gotten me quite excited about the whole conversation as well. I mean, the topic. So I will do some research further just to get myself, if there are videos available, I'm sure there would be, to see how.
Oh, absolutely, yeah. I think there's a lot of opportunity for AR, and unfortunately, I don't think many people are. Well, it just takes time. It's like membranes. When I first started 25 years ago, membranes were horrendously expensive, and so they were only used for specialist applications that warranted, the cost.
Yeah.
Same now, AR, and this is more your neck of the woods, but AR, it's not the implementation; it's the front end development. So, you're going to have to scan every single component, and then you're going to have to, so it comes back to, and, I guess the other thing would be CAD drawings, computer assisted design. So, that was sort of only really just coming out when I started my career, where they had the 2D, but you could do 3D. And a lot of the 2D software now will give you a 3D in the background. It's developing a 3D model. So you can take if it's a big plant, they'll call it a fly through. So you can go through and have a look at the layout, because obviously, the layout of your plant, especially when it's quite big, some of these things are holding thousands and thousands of litres of water, so they take up a lot of space. But also, just as importantly, when, a lot of the stuff I do is temporary and it's all containerized. So when you're putting all the stuff in, you design it, you can show it to an operator, or you can show it, or if it's yourself, and then you can see, I can't access that pump, or I can't access that switchboard, or something like that. So you can see it all before you've constructed it, and you can move it all around in a digital space before you go ahead and build the thing, and then find out that there's a problem.
It's quite intriguing. I mean, to your point about AI, a lot of time people think that AI is just like a computer software. You just plug it in and it just works. No, you have to train the AI. And a
Mm,
human being, normally AI obviously gets smarter as we transfer our own intellect to the programming. So the better you actually train the AI, the better it becomes. And that's I think it has its own limitation as well from that perspective. It depends on who is training that AI. That also accounts. So if you have a bunch of really smart people who are unbiased, really highly ethical people, they will make sure that the right information is fed into the AI and it's actually trained and programmed to that level. So the decision the AI makes after getting trained will be to that level.
mm. No, exactly. And I had a great boss who was, he did a lot of modeling, hydrodynamic modeling, and he'd say it wasn't, the models did the work, but he'd say, rubbish in, rubbish out. So you've got to understand what you're doing. And I think AI, if you look at something like a water utility, or anyone really, but on a water utility, training the AI, so the AI will help you, because these guys generate masses and masses of data. I think Southeast Queensland has one of the largest water distribution networks in the world. It's all linked up from the Gold Coast to the Sunshine Coast, basically. It's huge, and so sorry, I've got edible problems too. So training the AI or using the AI to predict. So, I can sit down, and I do sometimes looking through data to troubleshoot. Okay, so why did this happen? You're looking at root cause analysis. Why did this go wrong? Why do we have this problem? Why did this thing fail? But the amount of data that I've only got one head, and so I can only absorb so much information and just trying to draw all the correlations. So using AI to in a predictive manner, which says, okay, well, last time this was at this level, this was at this level, this was at this level, everything fell to bits. Now you don't want your operator or your the guy in the operations room to have to remember all that, because it's difficult. They'd have to be, and it might be 3, 4, 5 variables that result in a failure. But having AI, so this has happened again. It learned from last time that was a problem, and will alert you saying, okay, I'm predicting a failure. You need to take remedial actions now to address it. But I agree, sorry, you need you do need the right person at the other end teaching the AI what's relevant and what's not relevant, what's important.
Oh, fair enough. That was the right timing. Okay, that's basically my cue for next question. So, Daniel, how does drinking water treatment differ from your area of expertise? You mentioned that you've moved, you're no longer in that sphere. So you're more into commercial water?
So mostly industrial wastewaters.
Okay.
So drinking water. So you've got mineral processing and drinking water, and most of them. They employ a lot of similar technologies, things like filtration. You'll have things clarifiers, which are essentially large basins that let things settle out. The difference with drinking water is that you're trying to remove things from the water because you want the water as pure as possible. In mineral processing, you're trying to remove things from the water because the things that you're removing have value. So, for example, if you have a filter or a clarifier, so a clarifier is like a conical shaped vessel. You would, for drinking water, you take what's called the overflow, the stuff that comes over the top, which is nice and clean. That's your drinking water. And there's muck, which you dispose of down the bottom. For mineral processing, typically, the stuff that goes down the bottom, the solid material, that's what's paying the bills. That's what you're interested in. So, in terms of what I do, I have sort of, again, it's a bit of a niche, but I'm dealing with people's waste materials. So, and I guess, looking back, years ago, they'd just be able to dump it or get rid of it or whatever. But as legislation comes in and people are disincentivized from doing things like that financially, they're trying to, most of my jobs involve making large volumes smaller, so that, because typically you'll get paid on a per volume or per mass basis. So, if I can separate, I'm still using the same technology where I'm trying to create clean water, but clean water can go down a storm drain, or clean water can go into a sewer. that's okay. But I'll squeeze a large volume down to a small volume, and then all of the, I guess, nasties, if you like, they're sort of concentrated, and then they're dealt with by another process. But you're dealing with a much smaller volume, so it's cheaper.
Interesting. So, Daniel, I mean, fundamentally, what we also want to do is understand you're obviously a service provider, and we want people to know about you as well. So, who would be your typical customer, and who would also be your ideal customer?
So typically my customers are people with too much water, not enough water, or water of the wrong quality. So typically it's bad. I don't think I've found anyone. Oh, there's been a couple of people that their water's been too good. But so somebody, so in Australia, quite often, it's not enough water. And so they're having to resort to, and this can be it goes for drinking water as well, but it can go for industrial water. If you need water for example, mine sites use enormous volumes of water for dust suppression. So, but water that's used for dust suppression needs to meet certain guidelines, and you've got naturally occurring things like, there might be arsenic in the water, and that's naturally occurring, but you can't then go spraying that around a whole bunch of people. So, processes that are involved to remove nasties from water, conversely, so there's not enough water or there's too much water. So if you've got too much water, that can be a problem. And again, with mine sites, a lot of them just have a big sort of balancing act where they can't deal with the volumes that they've got on site. So my ideal customer would be someone who's gone out into the market and been told that nothing can be done for their water, because half of my work is developing new processes. So when somebody says nothing can be done, usually it means is that our process will not fit your problem.
So basically, they can't actually make that water useful. Is that what it is?
Yeah, that's it. So they can't, with their technology, they can't make their water useful. And then it starts that, okay, well, there's nothing out on the market that can do this. You're willing to invest a bit of time in some R&D where we can have a look at it and, try and get a process that works. And it's financially, it's a risk-based approach. So at the beginning, we know nothing, so we don't spend too much money. And then we agree on milestones essentially, so like, the first thing is to establish what are we trying to do here? What does success look like? And then we put a dollar value against that everyone's happy with. And then we do the first step and say, okay, no, this is terrible, throw it away, or no, this looks promising, let's move it to the next stage. And like any sort of R&D process, you start out probably not knowing as much, but as you start to narrow down, then it's safer from a financial perspective to invest more money into it because you've got rid of the number of unknowns.
So, I mean, obviously the water supplying companies or the usual water companies that we deal with from a drinking water perspective, those are your typical, used to be your typical clients, but now you're obviously moved more towards the mining industry, perhaps. Is it fair to say that agriculture?
Yeah, mining or just commercial industries. So I've got, so some of the projects I'm doing. So one client is a battery recycling facility. So they take batteries, crush them up, recover the acid, isolate the lead.
I think we may have lost you there, Daniel.
They can reuse the materials of the batteries. Obviously, I think they can recover the plastic as well. So things like that, where they've got, basically waste from an industry.
All right, so Daniel, I mean, yes, thank you for sharing the ideal customer and what kind of clientele what kind of people can approach you. I mean, in terms of industries, do you have a bit of an idea, or would you like to please provide some idea of what kind of industry do you cater to? So obviously, the water industry is one of them, but predominantly mining would be one, I think, based on the example you gave before.
Probably mining, oil and gas, water not so much, because there's industries, water they have fairly strong teams internally. So it's typically people that would, industries where they have to deal with water, but they're not a water industry. But they would like somebody with 25 years experience to come in and give them a hand out and either avoid pitfalls if I come in early, or clean up the mess afterwards. Because a lot of the issues are avoidable. It's a bit like it's like speaking another language, right? So I can give you something, a set of instructions, detailed, very clear instructions in a language you don't speak, and it just goes over the top of your head. But whenever you get a multidisciplinary team together at the start of a project and looking at it, everyone's looking through a different set of eyes. So having if it involves water or some sort of chemical process, having a process chemist can be very, very useful.
So can we assume that does your industry or does your business particularly tend to get a bit busier, say after a flood or heavy rainfall or something along those lines? Because these are natural disasters that could cause contamination in water and all sorts of things.
Sometimes it usually gets busier when new legislation comes in. So if new legislation comes in that says you need to crack down on what you're discharging or what can be discharged to sewer, or if they increase the rates, the tariffs on the disposal, then people basically do a cost benefit analysis and say, look, it's probably about time that we, rather than just paying somebody else to take this waste away, at least reduce the volume or reduce it where it's not a lower category risk, or so you pay less to reduce it. So that's in terms of the good thing about my career has been it's been exciting. I've never done the same thing twice, but the other side of that is I've never done the same thing twice. So I don't really have like I'm doing a job in Colombia at the moment with some guys, and they've got masses of water, and they need to empty a series of pits. So approaching me to say, okay, essentially they want it done cheaply, but it needs to meet the discharge criteria from the Colombian government. So did that answer your question?
It does. No, thank you. So if a particular person or a company wants to engage you, what's the best way to get in touch with you?
So 5 years ago, or for the last 5 years, it's been all basically word of mouth. So I've had third party referrals. Probably the best way to get to me is LinkedIn or email. You can email me directly, daniel.coudon@acol.com.au. I am actually just engaged. I've done a couple of projects now that are quite big and have involved small teams. So I've reached out to a marketing company, and they're going to be more proactive in going out and seeking people, which is good. And hopefully it brings in a bit more, sort of more of these larger projects where I can get, work with other people, other teams on a sort of a more ongoing basis.
Interesting. So just in the closure, if someone wants to collaborate with you, Daniel, what kind of people or skill sets would you be looking at? Would you be open for collaboration?
Yeah, absolutely. I love collaborating. I'm working with a guy here at the moment. He's got some products that he needs made, and he wants them made at a sort of a industrial level. So again, I'll go through and do the bench work for the small stuff, and then get an engineer involved and scale it up. Really, anyone that needs a chemist, I'm happy to work with. I like a challenge, and I've been lucky enough to have experience on a fairly wide range of projects. There's been mostly successful. There's been a few lessons learned in there, but they're the ones that stick with you, right? So you don't make those mistakes twice. Anybody who's looking to collaborate on water or sort of industrial chemistry processes, that would be probably the people I'll be looking out for.
Fantastic. Look, once again, Daniel, thank you so much for your time today. And if anyone wants to reach out to Daniel, his email is daniel.couton@acol.com.au, or you can look him up on LinkedIn. So thank you, Daniel, and hope to speak to you soon.
All right, thanks.